Hey guys, Zong here, back with another math video. Today we're going to be talking about limits. Now look at the question here. We have a limit as x approaches 0 of the quantity ax plus b square rooted minus 2 over x equals 1. What is a and what is b? So let's think about this. We only have one equation and we have to get two variables out of it. That seems a bit weird. That seems a bit wonky. Well, let's see how to do this. So what happens if we just plug in 0? We plug in 0, we get ax is just 0 plus b minus 2 over 0. And that's undefined. Whoops, undefined. Sorry, a bit of lag. Which means, in this case, we can't just find the limit by plugging in, 0. So that's strange. So what could ax plus b minus 2 over x, how do we make that limit 1? Well, let's think about how we find the limit. Conventionally, if a and b were defined, which we don't know a and b though, if they were defined, how would you find the limit? So let's see. Usually, if there's a square root minus a constant, or any type of square root minus any type of square root, I'd just take the conjugate. And taking the conjugate means you switch the sign of, okay, maybe it'd be better if I wrote it out. Taking the conjugate means just multiplying the top and bottom by ax plus b plus 2. And what's the conjugate of a number? Well, multiplying a conjugate of a number by the number gives you a squared minus b squared, which we all know the factorization is a plus b and a minus b. So if you have an equation that calls for a plus b, the conjugate is a minus b and vice versa. And what this does is, when we multiply the top and bottom by this, we get rid of the square roots in the numerator, because when you multiply these two together, it's just a squared minus b squared, so the numerator is gone. The square roots in the numerator are gone. So let's see what this turns out to. So this turns out to ax plus b minus 4 over ax plus b square rooted plus 2 times x. Here's where we get stuck. How the heck are we supposed to find a and b from here? Well, what normally happens is that we want to get x out of the denominator. And why is that? The reason we want that is because with x in the denominator, if we just plug in 0, the denominator will just equal 0, right? And if the denominator is 0, it's undefined. So we want to get x out of the denominator somehow. And to get x out of the denominator so we can just plug in 0 and get the limit to be equal 1, we need the top to also be a multiple of x. Because when you have something like nx over x, the x's cancel out. Currently, we have two terms in the top. We have ax plus, and this is the constant, b minus 4. In order for the top to be a multiple of x, and we want to cancel x out, keep in mind, b minus 4 will have to be equal to 0. And this is because we don't want a constant in the numerator when we want to cancel x out. And I'll show you why. So if b is 4, we set b to 4. Let's just go over there. If b is 4, then this becomes limit as x approaches 0, ax plus 4 minus 4 over a plus b plus 2 times x. And what this becomes, limit x approaches 0, ax over x square root ax plus b, ax plus b plus 2, bad handwriting. Now what's cool about this is that the x's cancel out, because there's no constant here. The b and 4 cancel out, so there's no constant, so the x's cancel out. Now we're left with limit as x approaches 0, a over ax plus, now b is 4, correct? 4 plus 2. Now we can set this equal to 1 since we know the limit is 1. What's cool about this is that there's no x in the denominator now, so we can just plug in 0, because now it won't become undefined when we just plug in 0. Let's try this out. So if we plug in x equals 0, that just means a times 0 is 0, so it's 0 plus 4 plus 2. This equals 1. Of course, you calculate this, you get 4 equals 1, and A equals 4. So now if B equals 4 and A equals 4, it seems to work out, doesn't it? Try it out. Plug A equals 4 and B equals 4 back in here, and you get a limit as x approaches 0, 4x plus 4 minus 2 over x. Take the conjugate at the top and bottom, multiply them together, and chances are you'll get something like 4x plus 4 minus 4 over x times 4x plus 4 plus 2. And of course, if you cancel out the x's, you get 4 in the numerator, 4 over this, and you plug in x equals 0, you'll probably end up with 1. So this seems to work. A equals 4 and B equals 4 seems to work. Now the major lesson you probably have to take here is that if you want the limit to be a cool number like 1, that means x has to factor out of the denominator, or whatever thing that's making your denominator 0 has to factor out. So for instance, if it's limit x as approaches 1 of like 1 over x minus 1, then you don't want x minus 1 in the denominator. You want to take that out and reduce it in some way so you can just plug the number in. Okay, hope you found that question enjoyable. I'll see you next week. 9 choices. I actually guessed an Amy problem right once, just by blindly guessing without even reading the problem, but other than that, usually guess and check won't work. But in this case, it actually will, and let me show you why. So let's assume, okay, because Amy gives you answer choices from 0 through 999, let's assume P is worst case scenario. Let's assume P is 999. Even though P is prime, we know, but it's a worst case scenario. P is 999.